Hey everyone, Dev again. This video is a bit different from what you might be used to. We're going over linear regression, the foundation of AI, and neural networks. If you don't master it, AI courses will be extremely difficult and it can even hurt your career. Many data scientists and ML engineers start off with linear regression whenever they're looking at a new dataset. Let's get started. One last thing. Instead of just lecturing, I'll walk through the Python code, line by line, and we'll even run our code against the test cases, ultimately solving this problem. The problem is from the LeetCode for ML platform that Navdeep and I created earlier this year. Now, let's get started. Linear regression is a simple statistical model that ends up being the foundation of neural network. We'll use it to predict someone's success on dating apps like Tinder. The goal is to predict an output Y based on any number of input attributes. For each input attribute, we have a weight, symbolized by W, and we sometimes add a constant term, B. These are called the model parameters. For this dating example, let's not worry about the constant term B. Each weight signifies how important the corresponding attribute is for determining the success rate Y. We could think of X1 as how attractive your profile photo is, X2 is how creative your bio is, and X3 is how clever or witty your pickup lines are. All of these numbers would be on a scale of 1 to 10. And we can think of Y as the predicted number of swipes you'll get on dating apps. The parameters start off totally random, but over many iterations of training, they are adjusted to increase the model accuracy on the training dataset. The training dataset might look something like this, where we have x1, x2, x3, and the true y value for every row. Over training, the model learns what characteristics lead to success on dating apps and which ones lead to failure. Now let's talk a bit more about the training loop. The gradient descent update rule is used to update the parameters across many iterations. With each update or iteration, we slightly improve the model's accuracy. If you're unfamiliar with gradient descent, I strongly recommend checking out the video that's about to pop up in the top right. It's the first ML algorithm I think everyone should learn. The video is just 3 minutes long and provides an intuitive and visual explanation of training. If you are familiar with gradient descent, let's finish explaining the training loop and jump into the code. This equation tells us how to update each parameter at each iteration. Let's use it to update W1, W2, and W3 at each iteration. The learning rate, alpha, is given to us as input, but what about the derivatives? Fortunately, we don't have to calculate the derivatives by hand since I provided the getDerivative function beforehand. GetDerivative just requires us to pass in the model prediction for the current iteration as well as the desired weight, W1, W2, or W3. If you're wondering why the derivative depends on the model prediction, let's look at the error function. We can see that the error function depends on the model prediction from the current values of W1, W2, and W3. So it makes sense that the derivative of the error function also depends on the model prediction. Within the training loop, we will call getDerivative 3 different times and apply the update rule 3 different times as well. Let's jump into the code. First, let's set up our training loop. Let's get the model prediction using the function given. This function simply multiplies 2 matrices using NumPy's matmul function. If you're looking to learn NumPy and PyTorch, check the top link in the description. The good news is that the rest of this code doesn't require a deep understanding of NumPy or PyTorch. If we multiply the training dataset x by a vector of weights, we end up with a vector of all the model predictions, with 1 entry for each data point. Let's call getDerivative for each weight, noticing that this function follows 0 indexing. Let's then use the derivatives to update each weight based on the learning rate and the gradient descent equation. We can finish by rounding our answer to 5 decimal places, and our code passes the test cases. I hope you've enjoyed this video, and I'll see you soon.